Hello, and welcome to this Xilinx Quick Take tutorial, which is going to provide an overview of the design flows within the Vivado Design Suite. The agenda is going to start off by introducing the system-level design flow diagram, which is a part of the ultra-fast design methodology. This diagram is integrated into the documentation Navigator, and it presents the entire Vivado Design Suite of tools with links to applicable collateral at each design stage. We'll then walk through the flow diagram and explain the various flow variations, including the RTL flow, the high-level synthesis flow, which is a C-based flow, and then how we augment the flow for doing embedded microprocessor design and partial reconfiguration. And finally, we'll introduce the main Vivado use models and discuss the advantages of using a reentrant project-based mode or more of a scripting mode with the non-project flow. If you're not familiar with the Xilinx Documentation Navigator, you really should be. It provides an excellent environment for filtering and navigating all of the various types of Xilinx documentation, videos, white papers, application notes, answer records, and so forth. There are several other quick take videos which focus on the various aspects of the Documentation Navigator. Notice that I've clicked on the Design Hub View tab, and the System Level Design Flow link on the left invokes the diagram. The background color shading indicate the various major design tasks. We've got the System Level Design Entry, which includes all of the what would be considered the design preparation tasks, such as RTL development, IP configuration, C-based design and synthesis with HLS, DSP design with the system generator, as well as any block design subsystems that are created with the IP integrator. And if you're doing embedded microprocessor design, there's also a software development task that runs in parallel with the hardware design task. And once the system level design has been created and assembled, we move on into implementation. And notice the various steps involved with implementation. And you'll also see partial reconfiguration in here, which is primarily an implementation tactic to enable that flow. And then once through implementation, you move into the hardware bring up and validation stage, which includes generating a bit stream, programming the device, and bringing up the hardware debug environment. Each one of these boxes has a link that will take you directly to the design hub that's associated with that particular design task. There's also a small little menu icon that'll provide a drop-down menu to the most commonly viewed collateral for that particular design step. And notice here I've got access to quick take videos, specific sections of the ultra-fast design methodology guide, tutorials, user guides, and so forth. Selecting the main blue link will take you to the design hub that's associated with that particular design task. Notice here in Getting Started, I've got access to all kinds of information on how to get started with Vivado. That same capability exists for the other design steps, as you can see here for configuring Xilinx and third-party IP. In the case of RTL development, we'll take you directly to the Ultra-Fast Design Methodology Guide to the section that addresses RTL coding guidelines. So the traditional RTL flow involves RTL development and IP configuration, so you'll see the arrow going down into the implementation part of the flow when using RTL and IP. One of the emerging design flows with our customers these days is the high-level synthesis flow using C-based technology. The high-level synthesis design hub provides a lot of information for users to understand the flow and to get started with the HLS tool. The Xilinx system generator tool has been around a while for doing DSP design, but there have been some recent enhancements to it. The system generator for DSP design hub will show you how to use the Vivado system generator in conjunction with the Vivado Design Suite. And one of the biggest features of the Vivado Design Suite is the IP packager and IP integrator. The IP integrator can be used to quickly configure and create IP subsystems using standard AXI interconnect protocol. And this enables very quick configuration, interconnect, and validation of the various IP and IP subsystems. Custom user IP can be packaged with the IP packager and used within the IP integrator, as well as any of the output from the high-level synthesis tool or system generator. Those IP can also be packaged and used within IP subsystems. This is also the main platform for doing embedded processor design within Vivado. Notice the Embedded Processor Design Hub contains a link to the Ultra-Fast Embedded Design Methodology Guide, which is a guide specifically tailored for doing embedded processor design within Vivado. And if you are doing embedded design, the Software Design link takes you to the Linux Tools Design Hub, which gives you a lot of information for doing the software development side of your design. Moving on down into the implementation stage, notice under Logic Simulation, there's direct links to the various simulation topics, including using third-party tools with Vivado. Notice the line that runs down the flow for logic simulation. Realizing that you can run logic simulation at various stages of the flow, including functional and behavioral simulation once netlists are compiled. And the same thing goes for assigning logical and physical constraints, as that can be done at various stages of the flow as well. The flow goes on to incorporate logic synthesis and implementation, as well as time enclosure and design analysis. And finally, into the hardware bring-up stage, you can generate bitstream, program the device. And if you are doing embedded design, here's where you can export to the Software Development Kit, or SDK, in order to provide boot capability for the processor. So that's the high-level overview of the entire Vivado design suite, including all of the various design flows that are integrated within it. And now I'd like to introduce the main Vivado use models, starting with the project-based flow. The project-based flow is a reentrant flow that creates a project infrastructure on disk to manage the entire design process, store results, and track status. It's used in conjunction with the Vivado IDE, which is a powerful integrated design environment to configure and manage the entire design process. This flow is typically used by GUI-based users, but the entire flow can be scripted in Tcl as well. There's another quick take video tutorial titled Getting Started with the Vivado IDE that covers the environment and flow in more detail. And the other use model, which is referred to as the non-project batch flow. This is a compilation style flow where the entire design project is compiled in memory and no data is actually stored on disk. The user controls the design and tool configuration, writing reports, and design checkpoints. Design checkpoints are a snapshot of the design at any current stage in the design process. The entire flow is Tcl-based, in that the user can enter Tcl commands or Tcl scripts to manage the design sources, tool commands, configuration, and so forth. This flow is obviously used by users that prefer a script-based approach, but the GUI or the IDE can actually be used at certain points in the flow for design analysis, constraint assignment, and so forth. The Tcl shell actually has two modes. There's batch and Tcl. And in batch, the example you see here, notice I'm feeding it a source Tcl script, which will simply run the script and exit Vivado. Using this simple example Tcl script, I'll walk through the main steps in the flow. First, you read in all the various sources. In this example, you see I'm reading VHDL and Verilog constraints, but I would also read in IP or existing block designs, etc., to first assemble the design. And then I'll synthesize the design targeting a specific part. Notice after synthesis, I'm writing a design checkpoint, which is a good idea, and running some various reports. And then into implementation, notice I've run it through placement and logic optimization, and I've also run some reports after that prior to routing. And then this example runs through route design and generates a checkpoint as well as a whole host of various reports before moving on and generating a bitstream. The Tcl command options are quite extensive in Vivado, and this is a simplistic example just to show the main steps. The other Vivado Tcl shell mode is Tcl. Notice here I've invoked the mode Tcl, and it invokes an interactive Tcl shell, which I can then begin to type the commands in one at a time. This allows me to directly interact with the design in memory as I'm compiling through the flow. There is another quick take video tutorial titled Using the Vivado Non-Project Batch Flow for more information. There are a whole host of quick take tutorials, tool tutorials, user guides, and methodology guides to help you get acquainted with the Vivado tool suite. Thank you very much for your time.
Thanks for viewing this quick take. If you found this video useful, you might be interested in taking some of our more in-depth training available at xilinx.com/training. We feature a variety of courses, both live and online, intended to make you proficient with Vivado and its features. We look forward to your participation. Thanks again for making Vivado successful.